Hello there, it's me again. Remember the 4 areas of setup work that need to be re-examined from Volume 1? Yes? No? Well, I'll remind you anyway. 1. Work procedures. 2. Organization of setup procedures. 3. Accuracy of equipment, jigs, etc. And 4. The work environment. Now, I'll let you in on a little secret. I have a passion for models. Plastic models, that is, not pin-ups, but stick-ups. But they're not as easy to make as you might think. The clue is proper preparation. We can apply our 4 points. Work environment. Here's mine. Lovely, isn't it? You need space to lay out all your tools and parts, and you need the right parts and sharpened tools. Work procedure. You certainly need a proper sheet of instructions telling you what to stick where and when, right? Unless you want to create a disaster. Of course, you've also got to keep in mind the distinction between internal setup and external setup, and make sure your basic setup procedures are fixed so that all your assembly parts are just where you want them. But this is only a hobby. Having problems and spending time thinking them over is part of the fun. But it's not much fun when it happens at work. Anyway, let's have a look at some ways we can improve things on our way to 0 setup losses. Now, where's that glue gone?
In order to reach for 0 setup losses, there are 3 fundamental steps to be taken. Step 1, rethinking setup operations. Step 2, reducing internal setup time. Step 3, from internal to external setup. Let's look at them in order. Generally, when you start improving setup operations, you deal with improvements to those parts of the job which take the most time. And in these cases, the effect of any improvements is, of course, relatively big. For example, this inspection sheet shows the time spent on 5 different setup jobs in one section of this factory. As you can see, by recording the times like this, you can easily set improvement targets. Once you fix the setup job targeted for improvement, you can work out how long each operation of the setup job takes, and then decide whether it's possible to carry any of them out as external setup operations. In this case, there are 12 setup operations in total. Analysis showed that 4 of these could in fact be done as external setup operations. That is, without stopping the machines. Over 13% of the setup time was being wasted. Of a total of 36.9 minutes spent for setup, 5.05 minutes could be done as external setup operations. Analysing setup time and clarifying how much of the setup is done as internal and how much as external operations is the first step on the path towards 0 setup losses. In this factory, they succeeded in clearly dividing the 2 types of operations, internal and external. At this machining centre, operators used to stop the machines to do all the required setup operations every time they exchanged jigs. After the analysis, the equipment itself was improved. Jigs were put on pallets and the exchange automated as much as possible. Equipment stoppage time was reduced to a minimum. Most of the necessary operations can now be done as external setup operations. In other words, if you can clearly distinguish between external and internal setup operations, you can save a great deal of time. To define whether your present operations are internal or external, you can check these points. 1. Before stopping equipment, are all the jigs, tools and dies accessible and ready for immediate use? 2. Are all the jigs, tools and dies cleaned and properly stored in an environment appropriate for exchange? 3. Do conditions allow immediate operation after setup has been completed?
Next, how about reducing the time we spend on internal setup? First, we have to check whether the equipment we're using is really suitable for the setup operations we have to do.
As an example, let's take a look at a machine where a part is attached using bolts. This is a die ring of a plastic moulding machine. It fits between the die head and the die itself and is firmly attached with several bolts. Before improvement, in order to change the die ring, all the bolts had to be removed. This took time and effort, and mounting the die ring was also a laborious job because it had to be held in place until the bolts were secured. The aim of the improvement was to increase efficiency and safety. Some of the holes in the die ring were redesigned as pear-shaped holes, like this. Now, when you remove the die ring, the bolts in the pear-shaped holes can be loosened slightly and left in place. During replacement, they're used to hold the ring in the correct position, while both men insert and tighten the rest of the bolts. In other words, why waste effort and time when it's really not necessary, and in fact inefficient and even dangerous? Now let's think about the possibility of simplifying setup operations involving complicated work. This is the die head of a plastic moulding machine. Normally a screen is installed to filter impurities from the melted plastic. The screen needs to be changed regularly, but because it's located inside the die head, it's usually necessary to remove the die head as well. As you can see, by mounting the screens on a slide that can be inserted, you can make the filter change a simple and fast one-touch operation. In order to reduce internal setup operation time, you really need to think about the original purpose of the operation and why it was organized in that way. Then you can discover unnecessary parts of the work and get rid of them. That's how to proceed with the process of improvements towards a more efficient system. It's well worth thinking about how to improve jigs as well as your other equipment. For example, if you are constantly having to change the jig position according to the dimensions of the product being processed, you obviously lengthen the total time spent on the process. In this situation, you must focus on essentials and proceed with what we can call functional standardization, so that resetting operations can be done without any messing about. For example, this diagram shows a jig used to process metal castings. Depending on the type, the diameter, and therefore the outside arc, varies. A V-block is used to ensure correct alignment of the castings. In this instance, the V-block has been grooved so that the castings joined together slot in precisely. Since the flanges on the castings vary in size, you would normally have to have a separate V-block for each type of casting. To avoid this complication, standardization of flange design was the solution. Since connecting castings is the main focus of this operation, the alteration of the size of the flanges does not affect any other operation. The result is an immediate improvement, whereby with just one type of V-block, various types of casting can be processed. If you can improve the equipment itself so that simultaneous removal and insertion becomes possible, then great savings in time and effort are possible. For example, in this case of die exchange. Before improvement, you had to remove the die used in the previous process and put it to one side so that a crane could carry it away. Then the crane would bring a new die to the working platform and install it in the fixed position. From removal to replacement is one work series. It was greatly improved by making both sides accessible like this. When the die is ready for removal, its replacement is waiting on a transfer cart. The new die is placed in position as the other die is removed on the other side. The new die is installed as the first die is taken away. In other words, it's quite possible for resetting operations to be carried out simultaneously.
How about your workplace? Have another look at the setup operations you do. See if you can find any that can be done at the same time instead of one after the other. Now, let's have a look at another major type of improvement we can consider with regard to internal setup. For example, when you change the type, you have to change the color.
Let's look at an example of changing the color of the plastic material inside a cylinder. The point here is how quickly you can change from one color to another. Normally you eject the previous color with the new. However, it takes time to do this because the two colors naturally mix together and there is a lot of waste before the proper degree of purity of the replacement flow is achieved. An alternative is to take the central screw out of the cylinder and replace it with a clean one after flushing, so that the color exchange operation will be speeded up. But to do this, it's necessary to remove the die head as well, and this might take even more time than would be saved by removing the screw. The answer is to change the position of the die head. If it is moved from the end of the cylinder and repositioned at 90 degrees to it, then removing the central screw becomes very easy without touching the die head. The positive result is a much more rapid color exchange. To shorten the time even more, you can carefully examine both the cleaning methods employed and also the operating conditions of the equipment, including temperature and pressure, to see if any further improvements can be made. Here are 3 basic points for speeding up internal setup operations. First, by improving jigs and tools for tightening, installation and removal is made much easier. Second, you should improve the system and structure of work procedures and setup operations so that simultaneous work becomes a reality. Third, you should investigate ways of changing colors and/or types.
We've looked at how to reduce equipment stoppage time by dividing clearly internal and external setup. And we've also rationalized internal setup. Up to now, we've had to stop the equipment to do assembly work. But what happens if we try to finish this kind of assembly work with advanced external setup? In other words, with your external setup, you can actually finish most of what has previously been internal setup and save lots of time. It needs some careful thought. Well, let's give it a go.
This equipment deals with the cutting and processing of spindles. It used to take a long time for alignment when installing materials. Effort was made to replace the detailed measurement work for this alignment by an external setup operation, using a highly accurate gauge standardized in advance. By attaching the required gauge blocks to the jigs, the spindle can easily be set in place with a simple one-touch lever. All the measurement work is replaced by the use of a combination of gauge blocks, making this an example of external setup operation. The work is reduced to simple choice of a combination of gauges. Next, let's check how we can transfer time-consuming adjustment work to external setup. Here's an example to do with the processing of camshafts and gear parts. This is called an eccentric cam. As you can see, the hole for the shaft is slightly off-center. Normally, in order to drill this properly, repeated fine adjustment has to be done to center the work on the chucks. To simplify this setup and eliminate the need for fine-tuning and adjustment, a custom-made jig was designed. The work is simply inserted into this jig and clamped by the chucks normally. It is centered automatically. The operation is now very simple. No delicate centering adjustment is required. This improvement has enabled all of the adjustment taken care of by jigs to be done as external setup rather than internal setup. Jigs like the one we've just seen are often referred to as trunking jigs or intermediate jigs. They're very convenient when you want to transfer time-consuming adjustment work to external setup operations. For example, when you want to change a bite for cutting and processing, normally you need careful alignment and measurement. However, instead of stopping the equipment to attach the cutting tool directly, how about thinking about putting it into a cassette-style holder? Both the jigs and the cutting tool platform can be standardized. The bite can be set in the holder. As a result, alignment and measurement can be done as an external setup operation. The adjusted bite, still in the holder, can then be removed from the trunking jig and simply set in place without any additional adjustment. There are three possibilities for adjustment work which can't be transferred to external setup operations. Avoid adjustment by using very accurate stoppers, blocks and gauges. Set necessary conditions such as electric current and air pressure numerically. Find the ideal procedure and prepare auxiliary equipment to speed up adjustment. These are all ways to reduce stoppage time. Now a summary of ways to reduce the number of internal setup operations. 1. Use gauge blocks to reduce measurement time. 2. Standardize jigs to get rid of adjustment. 3. Use trunking jigs for proper alignment and accuracy.
Done it! A model if ever I saw one. Well, did you get the 3 steps needed for heading towards 0 setup losses? To tell the truth, this model required a bit of trial and error. But a real factory production line certainly isn't the place for hit-and-miss efforts. I bet that if you take a good look around for possibilities for setup improvements, you'll find you have lots of them. How about a motto as a basis for all this? Something like, set up a setup that's safer, simpler, swifter, and sharper. Sounds a bit like Shakespeare. Sorry, I better see to my teeth. See you soon.